Okay, so this is the second part of today's class where we're going to look at forces in 2D. So basically just breaking components. It's a lot like, what we did in kinematics, but with forces this time. So force is a vector. So therefore, we need both the magnitude and the directions. Okay, so we need magnitude and directions. So if I give you a force and it has magnitude and direction, you should be able to break it up into x and y component. Or when you have to add two forces together, you do not just add the numbers, you have to add them in vector form. So let's look at an example. Two students pushes a crate across a frictionless surface. Okay, so you are being pushed on. Okay, so student A pushed with a 75 Newton. 75 Newton to the east. Student B pushed with a 48 Newton to the south. So 48 this way. So 75 Newton, 48 Newton. So what is the resultant force acting on the box? So when we add them, we don't just add 75 to 48. We have to add them in terms of vectors. That means we have to do head to tail as usual. So 75 Newton this way and 48 Newton this way, head to tail. And your resultant is going to be this right here, this blue one right here. That's your resultant. So you will need the angle and the magnitude. So this is the F, resultant, like total. Okay, so how do we get that? Well, we have done it like many times at this point. So Pythagoras theorem and the angle, right? Use tangent. So for F total, we can use Pythagoras theorem plus 48 square and square root. Okay, so that's pretty much it. So you get approximately 89 Newton at the end. But then you also need a direction, so you get it from using tangent. So tangent theta opposite is 48 over hypotenuse is 75. All right, so I move over there, and you get an angle that is approximately 33 degree. So 33 degree, and is touching. So now we go back and look at the picture. It's touching east, and it's going towards south. So we call it south of east. Okay, so that is a very simple example of forces adding together, right? Now, so sometimes we will try to break forces into components, which actually happens quite a lot. So when a force is not pointing in east or west or north, those perfect directions, you need to break into x and y components, just like velocity. So for example, you have a 35 Newton force, and you want to break it into x and y. So you break it into x and y this way, right? So the x side is going to be F1x, and this is going to be F1y. And since we have done it so many times, so this is 35 Newton with so this side is the x direction, which is close to the angle, so we use cosine of 20 degree. So F1x must be 32.9 Newton. So if you use the same thing, now then this side use 35 sine. If one side use cosine, the other direction use the sine one. So sine 20 degree, 35. This gives you approximately 12 Newton. Okay, so it's really easy to break them into components, just like how we will do the component for example, for our final velocity or initial velocity in last chapter. So break the force into component, just do sine cosine. Right, let's do one more. So in this one, we're trying to break this. So we start right there, 45 Newton, 50 degree. We have to go to the right hand side first and then go down. So one of them is down. So right here. So drawing arrows. So that's F2x and then F2y. Okay, so same idea. You just have to figure out which one uses x, which one uses y. So if you want to, pause the video here, figure out yourself. Okay? All right, now this is after the pause, I assume. So you should get 28.9 Newton for the horizontal and 34.5 Newton for the vertical. Now I do understand that this one, the vertical one, is supposed to be negative, but my diagram already points down. So I will remember that it's negative if I have to do any calculation. Otherwise, I would just leave it at that. Whereas your F3, well, that's nothing to break on this one, right? So the last vector is already in next direction. So there's nothing you need to do. Okay, so the reason why we added all of them, we break all of them into component, is to prepare us for this question, which is when you have to add the vectors together, when you have to add more than two vectors together, you cannot do the triangle method that we did in question 1, in example 1. You kind of have to do it by doing components, right? Now, but since we already broke F1 into x and y, F2 into x and y, and F3 doesn't have to break anything, so our resultant force, which is this force R, resultant, should be very easy if we just sum up the components into a chart. So that's what we always do, right? We do the chart thing. So we say like, okay, so force 1, and we have force 2, and we have force 3, and we are literally just adding them one at a time to get our resultant force, which is force R. Okay, so set up a chart like this first. And then we transfer everything that we have from the last part down to here. So for example, F1 x component is 32.9 and is pointing to the right hand side. F1y is approximately 12 and is pointing up, so it's positive, right? F2 is 28.9 for x. Now I do remember that, right? You think I'll forget? Negative 34.5 for y direction. And then for finally the F3, the force number 3, the first force is 65 Newton in the x direction, positive, and nothing on the y. So now we just add it all up. So if you add it all up, we will get 126.8 for x, negative 22.5 for y. Okay, so once we have this, it's really easy because all we have to do is to add them up. Draw from dots. So for example, from here, so go to the right hand side because you have 126.8 to go. That's in Newton. And then you go down by 22.5. So now you can get the resultant just like what we usually do, which is Pythagorean for the component. So this is the force resultant and angle